Every kid learns the same simple version of this story. A big rock fell from space, and the dinosaurs died. That's it. End of story, right? Wrong. Scientists have now pieced together something far more terrifying. A minute-by-minute reconstruction of the single worst day in the history of life on Earth. And here's the part nobody talks about. They also think they found where that rock came from, and whether something like it could be heading our way again. Buckle up, because what you're about to hear is more brutal and more strange than anything Hollywood has ever put on screen. Picture this. You're standing somewhere in what is now North America. 66 million years ago. Dinosaurs are everywhere. The air is warm. You glance up at the night sky and notice something odd. A point of light, brighter than any star, sitting almost still. Watch it for an hour. It doesn't move much. But it's getting brighter. That's not a star. That's a mountain of rock somewhere between 10 and 15 kilometers wide, screaming toward Earth at over 70,000 kilometers per hour, locked onto a collision course it can never escape. By the time it slams into our atmosphere, there is no stopping it. A small meteor burns up harmlessly, the way a pebble skips off a pond. This was nothing like that. This was a boulder thrown straight through a puddle. It barely slowed down at all. In roughly 3 seconds, it tore through 100 kilometers of sky, ripping out a sonic boom so violent it would have shattered eardrums across an entire continent. Any creature unlucky enough to be looking directly at it didn't get time to scream. It was vaporized on the spot. The impact site, a shallow sea near what's now Mexico's Yucatan Peninsula. The rock was moving so fast that the surrounding air couldn't even get out of the way. It compressed instantly, heating to thousands of degrees before the asteroid had even touched ground. That superheated shockwave alone boiled away much of the sea in the blink of an eye. Then came contact. The energy released was almost impossible to comprehend, roughly equivalent to 1 billion Hiroshima bombs going off at once. The ground itself, at the point of impact, briefly behaved like liquid. Rock flowed. Earth surged upward and outward the way water splashes when you cannonball into a pool. First an outward blast, then a delayed rebound that punched a wall of debris higher than Mount Everest into the sky, before it collapsed back down into what we now call the Chicxulub crater. If this exact impact happened today, the blast wave alone would vaporize anything within hundreds of kilometers, deafen people 1,000 miles away, and shatter windows on the far side of an ocean. The shock didn't stay local. It rippled through Earth's crust at several kilometers per second, triggering earthquakes across the entire continent. Somewhere on the other side of the planet, the ground would have started shaking within half an hour, just from the aftershock of an impact thousands of miles away. Then the water came. Tsunamis, not waves, but walls of ocean hundreds of meters tall, surged outward from the crater. Within the hour, they were crashing into the Gulf Coast, flooding dozens of kilometers inland, temporarily reversing the flow of rivers. Within 6 hours, they were slamming into the shores of Europe and Africa. Within 15 hours, every coastline on the planet had felt it. And this was still only the first day. Here's where it gets almost unbelievable. The force of the impact was strong enough to launch trillions of tons of pulverized Earth straight up, some of it fast enough to briefly leave the planet entirely, some possibly reaching the moon. But the overwhelming majority came straight back down as glassy droplets called tektites, ranging from marble-sized pebbles to chunks as big as a car, raining down across the entire globe at hundreds of kilometers an hour. It didn't matter if you were a dinosaur standing right next to the crater or one grazing peacefully on the far side of the world. This rain of molten glass was falling everywhere, and as it burned through the atmosphere, it radiated enough heat to set forests ablaze across entire continents. Within hours, much of the planet's vegetation was on fire. This single detail explains a strange fact paleontologists still find in the fossil record. Almost no ground-dwelling large animal survived unless it could hide. Creatures that could burrow, like early mammals, snakes, and lizards, made it. Creatures that could dive underwater. Crocodiles, turtles, made it. Birds that nested and sheltered on the ground survived. Birds that nested in exposed trees mostly didn't. Everything else, out in the open, simply had nowhere to hide from a sky that was actively burning. As if fire and tsunamis weren't enough, the asteroid happened to strike one of the worst possible spots on the entire planet, a region absolutely loaded with oil and sulfur deposits. The impact instantly vaporized an almost inconceivable quantity of both. Tens of billions of tons of sulfur and enough water vapor to fill oceans, all thrown into the atmosphere at once. That vapor condensed into monstrous storm systems that fell back down as acid rain, poisoning oceans and burying entire regions under feet of snow, even far from the poles. But the sulfur and rain eventually washed out. The oil didn't behave the same way. Instead, the vaporized petroleum rose high into the stratosphere and formed a thick, black layer of soot, essentially wrapping the entire Earth in a lid of smoke, far above the clouds, where rain could never wash it away. That soot layer blocked roughly 90% of incoming sunlight for 2 to 3 years straight. The fire that scorched the planet in its first few days was followed almost immediately by the opposite extreme, a years-long deep freeze. Global temperatures crashed by nearly 30 degrees Celsius on average. Photosynthesis collapsed. Rainfall dropped by as much as 80% almost everywhere on the planet outside a small handful of tropical regions, modern-day Madagascar, India, and Indonesia, that happened to be positioned just right to dodge the worst of it.